Hey guys, today we're talking about our last form for linear equations. We've talked about this first one, slope-intercept form. This is the pretty one. This one, they give us a slope, m, and they give us our y-intercept, b. And it's all right here. So I can look at this and know exactly where my beginning is by looking at b, and I know what my slope of my line is going to be, my steepness of my line, just by looking at it. Yesterday, we talked about this form, standard form. It was not as pretty. We had two options for this one for graphing. Option one was to solve for the x-intercept and the y-intercept, graph those and then connect the dots. And option two was to solve for y and get it in slope-intercept form. That way I could just look at it and find the slope and the y-intercept. Today, we're talking about this form. This last form here is called point-slope form. And again, we're math people, we're not creative. And the reason it's called point-slope form is because it gives you a point and it gives you a slope. So let's look at this here and figure out what all these letters in this equation mean. So first we've got this x1, let me not write in yellow, x1 and y1. This represents a point. So they're going to give you a point, and that's my x and my y1. So if you look in the equation, here is x1, and here is y1. Then the slope is represented by m, just like in our slope-intercept form. M means slope. That's the letter that we use to represent it, and that's located right here, and it's always, always, always going to be next to the parentheses. Then you have just a plain old x and a plain old y. That represents all the points on the line. So if we have a line, we have infinitely many points on the line, and those are located right here. There's the y. Oops. There's the y. And there is the x. This form is used when they give you a slope, your m, and a point, your x1 and your y1. So let's look at these two problems here. This says y plus 2 equals negative 3 times x minus 2. So it wants us to identify the slope in this equation and also the point that was given to us in this equation. Well, I can always identify the slope because it's next to those parentheses. So if you remember the formula, again, it was y minus y1 equals m x minus x1. So my slope is right here next to the parentheses, and in this case, my slope is negative 3. So that's my m. So for point-slope form, it's also pretty easy to identify the slope. The point, I have to look at that x1 and that y1. So here's my x1. Here's my y1. Now I've got to look at these points pretty carefully because in the formula, if you notice, they always use a subtraction sign. They're always being subtracted. So if you think about it, if I plug in a negative 2, I would have minus a negative, which really turns into a positive. So that's what's happening here. I plugged in a negative 2. So my y is actually negative. If I plug in a positive, though, it's automatically subtracting it, so it's going to look negative in the equation. So here has a minus 2, so actually I plugged in a positive 2. It's just opposite of what you think. So my point would be 2, negative 2. And also remember your y is the first one, so x comma y. Let's look at number next. Again, I have my formula y minus y1 equals m x minus x1. My slope is always, always, always next to those parentheses. So this one I can just look at it and see my slope is negative 2. Then I look at these points over here. And I've got my y1 is a negative 1/2 and my x1 is a positive 1/2. So if I look at x first, it's a positive, but when I take it out of that formula, because of that negative sign, it's actually going to be opposite. So instead of being positive, it's a negative 1/2. And then same thing with y. He looks negative, but when I take him out, it's going to be a positive 1/2. So my point is negative 1/2, positive 1/2. So you're able to look at the formula and identify the slope and the point. Well, what if I give you a slope and a point? Can you write the formula? Here's the steps on how to do that. First, identify the slope, find your m, and they're going to give it to you. Step 2, label your points, x1, y1, and then you just start substituting into your formula. So let's look at number 3. My slope is -2, and that always goes next to my parentheses. So I'm going to put -2 here. That was step first. Step number next was to label my points. So here's my x1 and my y1. So I have y minus y1 and x minus x1. So x1 is 3 and y1 is -1. When we go to plug in though, so I've got y1 as a -1, minus a negative is really a positive. It's kind of ugly to say minus a negative. So we're going to change that to +1. Or if you just want to remember, hey, when I plug it in, I've got to flip the sign, or when I pull it out, I have to flip the sign. That's another way to think about it. The x1's a +3, so again, when I plug it in, it's minus, so it has to be -3. So there's my formula for that one. Y plus 1 equals -2 times x minus 3. Next one, slope always goes next to the parentheses. -2/3 is my slope this time. Then I go to label my point, x1 and y1. In this case, my y1 is 0, so I have minus a 0. Anytime it's 0, you really don't have to put it. So we could just leave this part out, because if I add or subtract a 0, it's not going to change anything. There's no value there. So y equals -2/3 x. My x1 is 4. It's a +4, but remember when I plug it in, I've got to change that sign to make it negative. So there's my equation. Let's look here. What if they don't give me a slope and all they give me is 2 points? Well, to find slope, all I need is my 2 pretty points. So first I would find the slope. And then step 2, I would use the point slope form to find the equation. So like number 5, I've got the 2 pretty points. So I'm going to plug it in to my equation for slope. And again, you don't have to memorize any of these formulas. If we go to our formula chart, I have it linked in Google Classroom. Here's standard form, slope-intercept form, point-slope form, and slope of a line. It's all right here if you need to ever refer to it. So to find slope, I've got m equals y2 minus y1 over x2 minus x1. And then I just start plugging it in. Here's x1, here's y1, x2, y2. So my y2 is 5 minus my y1, which is 6. Then I have x2 is -2, and my x1 is -4, but it's minus a negative, which again, that's ugly. Let's just say plus. 5 minus 6 is -1, and -2 plus 4 is +2. So my slope is -1/2. Well, now I've got my slope, and I've got a point, so I can find the equation by plugging it into my fancy slope, point slope form. Y minus y1 equals mx minus x1. Then we're going to start plugging it in. My slope was -1/2, so I'm plugging that in for m. -1/2. Then I need to look for my y1. I'm going to use this first point here. It does not matter which point you use. I'm just going to use the first one because he's right there. It's a +6. positive 6. So I have y minus, y minus 6 equals negative half x, x minus x1. Well, my x1's negative 4, so minus a negative again is just a positive. So there's my equation. Now, if you're looking for the slope and your b, your y-intercept, you can solve this equation to find that as well. So I can take my equation and solve for y, just like we do every single Friday. Y minus 6 equals negative half x plus 4. First, I'm going to distribute. I'm going to simplify. I've got negative half x minus 2 and y minus 6 on this side. I've got a y side and an everything else side. Everything that's not y is going over there. So this negative 6 can't stay on the y side, so I've got to do the opposite or inverse and add that. Whatever I do on one side, I do to the other side. I've got y equals negative half x and a negative 2 plus 6. They're different signs, so I subtract and keep the sign of the bigger number. So I've got positive 4. Okay, so that's the formal way to do it. But again, we have Desmos, so we can cheat. I can plug this all into Desmos and get my formula as well. So if I go to Desmos, I'm going to press this plus sign up here at the top, and then I press table. I'm given my 2 points here, negative 4, 6 is what I'm going to plug in to my first one, and then negative 2, 5. I keep those points there, and right underneath it, I'm going to type in y1, the little squiggly thing, mx1 plus b. And if I look down here under where it says parameters, I've got my m and my b given to me. And my m is given in a decimal. If you just type m in and press the fancy fraction button, it'll turn into a fraction for you. So my m is negative half and my b is 4. So if I were to write an equation, it'd be y equals negative half x plus 4, which is what I got over here. So I would just bypass all of this and plug it into Desmos if I were you. This next one here, there's 2 things you could do. First, you could take these points, plug it in Desmos. I think is the easiest way to do it to get your slope and your y-intercept. Or you can count up, rise 1, 2, 3, 4, rise 4 over run positive 2. So my m is rise over run, which is 4 over 2, which simplifies to 2. And I have a point. I'm just going to pick this point here because he's already there. Y minus y1 equals m x minus x1. So when I go to plug it in, I've got y minus, my y1 is a negative 2, so it's really y plus 2 equals my m was 2, x minus a 1. And if I wanted to solve this, I could. Y minus, I'm going to, sorry y'all, being kind of slow. Draw my line. I'm going to have a y side and everything else side. First, I'm going to simplify. I've got 2x minus 2 on this side and y plus 2 on this side. Only y's can be on the left, so I've got to get rid of that 2 because he doesn't have a y. So I'm going to subtract 2 from both sides. And I'm left with y equals 2x minus 4 would be the equation. Again, if you want to skip all this math and cheat, we also have that option. If you go to Desmos, again, you hit your table button. I plug in the 2 points it gave me, 3, 2, and 1, negative 2. 3, 2, 1, negative 2. Underneath it, I'm going to type y1, squiggly, mx1 plus b. And down here, it gives me 2 and 4. So if I were to write my equation, it'd be y equals 2x minus 4, which is what we got over here. Number 7 says, write a linear function f whose values f of 4 equals negative 2 and f of 12 equals 10. Okay, so normally it tells us f of x equals a number. And remember, f of x is just a fancy way of saying y. So whatever I'm plugging into my function, remember my function machine, that's my x or my input. So my x is 4. I'm inputting 4, and when I plug it in, -2 comes out. That's my output, or my y. So if I were to write a point for this, it would be 4, -2. Same thing over here. F of 12, I'm plugging 12 into my function machine. That's my input. And then when it comes out, my output is 10. So my point would be 12, 10. Well, look, I'm given 2 points. I can find it. I can go the long way and find the slope and then plug it back in. Or again, go to Desmos, plus sign, table. My first one was 4, -2, and then 12, 10. Y1 squiggly mx1 plus b. I look down here, my m is a decimal, so I'm going to type in m, hit the fancy fraction button, is 3/2. So when I go to write my equation, I've got, let's see if I can split this over here, m equals 3/2 and b equals -8. So y equals 3/2x minus 8 would be my equation for that. And of course, we can't end without doing a word problem. Jeremy is driving at a constant speed of 55 miles per hour. And pers are one of those words that means multiply. So I know that 55 here is my slope, because whatever number's next to my x is always my slope. So there's my slope. It says after driving 4 hours, his odometer reads 280. So if I plug in 4 hours into my function machine, my x, my output is y. So our problem, the information that's given to us, we're given an m. Our slope was 55 miles per hour. And I was given a point. If I plug in 4, I get out 280. Well, then it says write a linear function in point-slope form. Well, I can do that. I'm given a point and I'm given a slope. So y minus my y1 is 280. So minus 280 equals my m, which is 55, parentheses x minus my x1, which is the 4. And I'm going to plug that in. Gives me my point-slope form. And then in C, it says write the above equation in slope-intercept form. So all I have to do is solve for y, get y by itself. I'm going to draw my line, simplify the left, and I've got y minus 280 equals 55x minus 220. Again, I'm going to have a y side and an everything else side. Negative 280 can't stay on the y side. He didn't have a y, so I've got to add 280 to both sides. So I'm left with y equals 55x plus 60. And there it is in slope-intercept form. So I can look at it and know my slope is 55, and my beginning, my y-intercept is 60. And then last question, it says, what distance is displayed on the odometer after 9 hours? So 9 was what I plug in. That's my x, and I want to know my y, how far I've gone. Well, now I have a fancy equation I wrote, y equals 55x plus 60. So everywhere I see an x, I'm going to plug in 9. So I've got 55 times 9 plus 60. Let's cheat on this one because y'all been working hard. I'm going to take everything I see here in yellow and I'm going to put it in Desmos. So I have 55 times 9 plus 60. And I get 555. So y equals 555. So after 9 hours, I've driven 555 miles. And that is point-slope form. Again, if you're given a point and a slope, then you can solve the equation using the point-slope form. Please complete your homework in Google Classroom. Bye, y'all.